I'd like to welcome everybody to this discussion today about engineering technology and how it figures in and folds in with the field of engineering as a whole. So I will go on ahead and just, I believe, go into some pretty general information about the area of engineering technology before I drill down into the ODU programs themselves. Okay, so there are, if you go on the internet or go to reference material and look up things like what is engineering technology mission, any of those types of things, you can find several different presentations or explanations. But I think this one is as appropriate or more so than any of them is that engineering technology is the profession in which knowledge of mathematics and natural sciences gained by higher education, experience, and practice is used to create and enhance technologies that benefit humanity. Now, you could take the word technology out of that first line, and I still think it would be a pertinent definition. Okay. So, engineering technology and engineering are the same in many, many respects. All right. We'll talk about the differences here in a minute. But I also want to highlight, too, the last phrase that create and enhance technologies that benefit humanity, because at the end of all of this, that is why we're in the business. Okay. And this is why we study and practice engineering and engineering technology in this particular case specifically. So just a few quick points here on how technology has developed over the years. This is certainly by no means a complete timeline, but I do want to point out a couple of things. Certainly, the Industrial Revolution in the mid 1700s and how that basically started everything rolling with regard to the advancements and the rate of advancements in technology and engineering and science for that matter. So James Watt and his improvements to the steam engine are a landmark event. Certainly, the conquering of the air by the Wright brothers at the turn of the last century was a tremendous event and launched the aerospace industry. And the advent of computers, which is just so much now a part of our existence and our daily lives, which came about in their more current incarnation in the early 1900s, specifically around the time of the Second World War. And ever since that time have been progressing at various rates with regard to speed, capacity, and density. This one is very, very important when it comes to engineering and engineering technology to see where things have changed and how the two fields have somewhat diverged, not much, but have somewhat diverged. And certainly the launch of the Sputnik in 1957 and the genesis of the space age had more to do with the advances in technology during the last century than any single event. And at this point, this is where we started to use the term engineering technology a little more liberally than just engineering. Okay, now ET programs came into existence just after the Second World War and became more prominent after the birth of the space program. In fact, a lot of people don't really consider engineering technology being a separate field until truly the beginning of the space race in the 60s. Now, what changed? Well, before that, okay, before the middle of the last century, engineering was engineering. Okay, you basically what I would refer to as you had the big three. You had the civil, the mechanical, and the electrical, which was the latest of the three, just because there really was no electricity to be had before the very, very late 1800s. Okay. But those three pillars of engineering, if you will, or fields of study, went through the first half of the 1900s. And then we get to the 50s and the 60s. And what's changed there is now we're starting to talk about computers. Now we're starting to talk about electronics. Now we're starting to talk about these things that are really going to, dramatically change and shape what we're doing from an engineering standpoint. And during the space race, it was decided and evolved that there needed to be a group of engineers that worked on the more theoretical, the more groundbreaking, the more unattainable technologies at that time than the actual engineers of practice. And the engineers of practice who are the ones that would utilize these developments for that definition we showed you earlier for the advancement of our lives, basically. And so at that time, we started to use the terms engineering technology and engineering somewhat separately. In fact, the engineering field, a lot of people, especially technologists, refer to that as not just engineering, but engineering science, because that is a branch of engineering. It is the larger of the two branches, certainly, but it is still a branch. But we drop the term science a great deal, most of the time, and just call it engineering. And then engineering technology somewhat split off to be the more applied. So just as an example, what is the difference maybe between engineering and engineering technology? Well, when you're on the engineering or the engineering science side of things, your education, your background is going to more lend you toward complex design. A lot of this has to do with the curricula that you are exposed to as you're going through your both your undergraduate and in many cases your graduate work. And these give you the tools to work more on the complex designs, okay? And for example, here we have the space shuttle and we have the part of the jet engine here, and then just as a bonus, we have this very complex function at the bottom to show that a lot of that is going to be coming from these more advanced topics in mathematics. Applied design, which is where engineering technologists thrive, is they take the technology and the science and the state of the art that's presented and are able to incorporate these things into the products which we and items which we use sometimes quite regularly, but even more uniquely. But still, it's an applied approach to engineering. Okay. And what we have here are obviously parts and pieces, cogs, bearings, these types of things that we be fabricated. Circuit boards. This is actually a microcontroller board that have basically you would find some variant of this in just about everything that has a plug. And then obviously structures, wind turbines, things of that nature, bridges, etc., that would be basically the domain of the civil and the mechanical engineers. Couple of bullets here. Engineering technologists use knowledge of science and math to make bridges, buildings, computers, machines, that should be plural, sorry, and transportation systems that we rely upon. To become an engineering technologist, you must earn a baccalaureate of science and engineering technology degree. Okay. There are 2-year degrees, all right, that can be built upon to attain the bachelor's degree, which is something that we certainly encourage happen. But you're really not considered in the engineering community. You're really not considered an engineering technologist without the 4-year degree. Okay. So this is a visual that illustrates where the differences are and the overlaps are between engineering and engineering technology. If you look on the left, you see it starts at research all the way on the left-hand side, and as you go clockwise 180 degrees, you end up over in service, maintenance, distribution, and sales. And as the basic independent variable here on the horizontal is math, okay, and advanced topics in math and science. And so if you're going to work in research, for example, you're going to need more exposure and experience in higher level mathematics and science. But but the practical aspect of it may not be as important. Okay. You may not be working in a manufacturing or a implementation role. It's more about, developing new science and technology. Over on the right hand side, we have things like, the maintenance, the service, operation, production, those types of things, and even distribution and sales, where if you are selling technical products, having a technical background is invaluable. So on the left hand, we see right here, let me see, I have a pointer here. We have this arc, which is in white, which represents engineering. And that arc swings all the way from research probably over to the production area. Now, if we go over all the way to the right and we look at the yellow arc, it starts at the distribution and sales and comes all the way over to between development and complex design. Okay. You can obviously see that we have this wedge in the middle where you see a great deal of overlap. And so these are traditionally and very commonly areas where engineering and engineering technologists overlap and perform the same functions. Okay. Usually production, routine design, test and evaluation, manufacturing, and even product development and system development would fall into those categories. Engineering technologists, which generally stop at the baccalaureate degree, are not going to generally be going into these areas unless they go and go to graduate school, study further, things of those along those lines. But you can kind of see where the overlap would be. Also, too, does that mean nobody with an engineering degree can be in operations or service or maintenance or distribution or sales? Absolutely not. These are not hard lines by any means, but they do represent probability, okay, of where people are going to be working. Where are the jobs typically for engineering technologists? Well, again, without really the background and the graduate degrees that go with it, you're probably not going to be working in research. Okay, and so this is really more in the domain of the engineer. But then as we start to head through complex analysis and design, and then you get to manufacturing and routine design, that's where the opportunities for the engineering technologists greatly open up. So, engineering versus engineering technology, what about the math? Okay, because that's a common question that people have. Well, if you look at the engineering technology curricula and the engineering curricula, the first thing that should jump out at you is the difference in the math that's required. Okay, for example, at our institution, Calculus 1 is the top level of math that is required for all of our engineering technology programs. You go into the engineering programs, that is generally going to be something like Calculus 3. And then, depending, for example, if you're going into electrical, it might even be beyond that. And so there is a difference there. So what we don't address in engineering technology when it comes to math, we use those credits to basically put more hands-on practice type of courses in place, laboratory-driven courses to provide that type of knowledge to the students. And a lot of people say, might ask the question, well, why, how often do you use calculus in the job? Well, my response to that would be, it depends on the job. Okay. And many jobs, you're not going to use much, if all, at all of the calculus. If you're going to grad school and are going to be moving in that track, you're probably going to get exposed moderately to excessively those topics. So it all depends on where you are and what you're doing. But for the vast majority of things, the engineering technology educators feel as though that Calc 1 is sufficient for our graduates to move forward in their careers. Now, here are a couple of slides that basically try to point out again the difference between engineering and engineering technology. If you look at an engineering program objective, it may be phrased like to provide the knowledge required to apply state-of-the-art techniques and designs to meet the current needs of society. That's a very understandable and kind of typical program objective for an engineering curriculum. On the engineering technology side, emphasis is placed upon applying current knowledge and practices to the solution of specific technical problems. When it comes to expertise objectives, engineering, the curricula greatly favors the idea of developing conceptual capabilities. And again, engineering technology is more about developing application capabilities. And I purloined this from the Engineering Technology Council of the ASEE here in the U.S. And I think this sums it up very well. The degree is engineering technology, the career is engineering. Okay, so it is part of the same pie, if you will. So, what type of title can an engineering technologist expect when they're out in their careers, okay, and during their careers? Well, this was from a study now 8 years old, performed by a gentleman by the name of Ron Land, and it's basically the results of a survey, a very large survey that had been deployed regarding where engineering technologists fit in to the workplace. And as you see along the horizontal axis here, we have many titles that are used in industry. And I'm sorry for the quality of this, but this is just the way it was available originally. But anyway, if you can see across the bottom, you see things like engineer, senior engineer, field engineer, test engineer, sales engineer, etc. You go all the way to the right, you see things like technician, engineering trainee, and then other. We have a stacked bar graph here. And the thing, basically what I'm trying to point out with this slide is that the blue, okay, which may look white on some screens, but the blue bars here would be the professionals who have the Bachelor's of Science degree in engineering technology, okay? And you see that the BSET, all right, cutting it short, the BSET degree can lead to the title of engineer. It can lead to the title of senior engineer. In fact, it can lead to any of these titles whatsoever, okay? And so, and the green in this case are the confirmed graduates from engineering programs. And then the red, which is the largest of the bars, were not distinguished by the actual employers. Quite honestly, I suspect because the employers didn't know or didn't care to look it up, or chose not to look up the information. All they know is that the persons they were speaking of had bachelor's degrees in engineering or engineering technology. So that's why we have either down here. But the point is, what I'm trying to make is the engineering technologist can fill any of these roles at any given time. Now, also as part of this survey, they talk that there was some more subjective feedback that was tallied. And here are just a few bullets I'd like to extract and show you from this. With regard to the capabilities, was stated on many occasions in the survey that BSET graduates are often more comfortable proceeding without detailed direction than traditional engineers. BSET graduates are better prepared to hit the ground running. That term was used multiple times. And traditional BS engineering graduates, which is the engineering science side, are more theoretical and less hands-on. So these were inputs that were offered to the survey repeatedly between the engineers and the engineering technologists. So when we look at the Department of Engineering Technology at Old Dominion University, our programs, lead to the Bachelor of Science in Engineering Technology. That is the degree. And we have programs in civil engineering technology, electrical engineering technology, and mechanical engineering technology, all three of which are accredited by the Engineering Technology Accreditation Commission of ABET. And that is the standard for engineering technology accreditation, certainly in this country, and now it's becoming more of a global type of rubber or stamp, if you will. We also have a program that is offered and administered through the interdepartmental studies of the university in general engineering technology. Unfortunately, that program is not accredited, but it is supported by our department. And that particular program is the general engineering technology program, studies all three of the above areas to some level. Okay, so it's basically kind of scratches the surface of these three above to give a broader background than any of the individual civil, electrical, or mechanical in their respective areas. But it is, again, I'd like to point out, it is not ABET accredited. So civil engineering technology is the first of the three. Dr. Michael Seek is the program director. He's been doing it now for not that long. He jumped on board about 6 months ago doing the job, and he's doing a great job. And in civil engineering technology at Old Dominion University, we have three separate areas. We have construction management, we have an area in structural design, and an instruction in site development. And basically, the first several years in the program have very common core courses that are taken. And then when you get to the end of that junior year and throughout the senior year, that's where you see specialization in these three areas, okay, and the student's ability to choose one of these three. Where are the jobs for our CET graduates? Well, municipal engineering departments, civil engineering consulting firms, structural design firms, land surveying companies, construction companies, public utilities, and also highway departments. And these are just to name a few, okay, or name several. The electrical engineering technology program, Dr. Otilia Popescu is the program director for the EET program. And the bachelor degree in electrical engineering technology offers a specialization or a concentration in the embedded system area, the mechatronic system area, the power systems area, communication systems, and also computer engineering technology. The computer engineering technology concentration is somewhat different than the other four because it's going to be a little bit less of the electrical courses and a lot more programming. Okay, so that it looks very different than the four above it. Where would our EET graduates find careers? Well, certainly in these: aerospace industry, automation, automotive, communications, computers, electronics and controls, industrial equipment, instrumentation, the medical field, and also power generation and distribution. And then lastly, mechanical engineering technology, which is the largest of the three programs. Civil and mechanical are very close to one another with regard to their enrollments. And Mr. Nathan Lutke is the program director. He's been with the university for quite some time. And the areas of specialization in the MET program are mechanical system design, manufacturing, nuclear systems, mechatronics, and marine systems. And our MET graduates will find employment in these industries, certainly, as well as others, but we have maritime, shipbuilding and repair, automation, automotive, quality assurance, plant operations and management, power generation. A lot of our MET students can go to the utility industry. Then we have industrial equipment, instrumentation, product and manufacturing, system design, testing and evaluation, and then also technical sales. When we're talking about the size of the programs here are some statistics. The ODU awarded, Old Dominion University, awarded 150 BS degrees in ET during the academic year 2018-2019. Don't have the more recent numbers. These are the most recent numbers that I have right now. Now, from a national standpoint, we are tied for 18th in the number of degrees awarded to our engineering technology graduates over that same time period. Enrollments in our programs are the 14th highest in the U.S. as of 2018, and ODU is tied for 16th in the graduation rate of women in engineering technology for the same time period. So, summing things up, a few frequently asked questions. Okay, what type of job am I going to get? Well, it runs the gamut. You would be employed or find work certainly in any area in the technical, all the way up to management levels. When you've had some experience in the job, those management opportunities could come available. Starting salaries, it's somewhat all over the place, but I think a good ballpark is in the 50K to 70K range. I know for a fact that a lot of our students do better than 70K coming right out of school. It all depends on, just like any job, it all depends on right place, right time, right skill set. Okay. Now, a couple of data points here, and this is supported by some information at the website, which I've noted on this slide, that for engineering technologists, mean annual salaries for people who have been practicing for some time. Obviously, this is not only new employees, but people that have been working in engineering technology their entire careers. But it's very common for that to be in the 85K up to the six-figure range. And then when you look at the top 10% earners, you're talking about the mid 100s, okay, or the mid 1 to 200 range. So 150K as a salary is very, very realistic. And by the way, when you compare this to their engineering counterparts, what you find is these numbers are essentially the same. Okay, so although the engineering technologist may not command as high an initial salary as the engineering graduate would, might be slightly lower. As time goes on, those discrepancies disappear, and that's generally what's found and has been found historically. Licensure, which is always a question that pops up, especially in the civil engineering technology side of things, as well as the mechanical, electrical, not so much, but in the certainly in the civil, and then very often, I should say, in the mechanical. So how does it work? Well, for engineering, that track, the road to licensure after you graduated from an ABET accredited program, there is the fundamentals of engineering exam, upon a successful completion of which you become an engineer in training. After 4 years of experience, then you are ready to take the PE exam if you so choose. If you pass that exam, then you can obtain your license. For the engineering technology, it is the same track, graduating from an accredited engineering technology program, but generally, not always, because each state can be different, there is an additional year of experience that is required for before you can take the PE exam. Okay, so that really is going to be the only difference. Now, for details about the licensure process, the place to go is the NCEES, and the website is listed there at the bottom. Okay, and they will give you more information. Now, not all 50 states allow engineering technology graduates to sit for licensure. Okay, and that needs to be pointed out. There are some states that do not offer that, and but right now, I think the last number that I was aware of is that out of 50 states, somewhere in the mid 30s of the number of states do allow engineering technologists to sit for the licensure examination. All right, so that's the end of the planned presentation, and I will hand it back to Orlando to see how he would like to proceed.
Yeah, I'm gonna hold on to the question for now. I'm gonna give the opportunity to Alex, Richard, and Eric to jump in and give your own experiences as students and as professionals. Well, Alex, you're still there, but you have some internship experience. Eric graduated in December. Am I right, Eric?
Yes, it was December of 2019.
And you, Richard, I forget.
Just graduated in May.
In May. All right. I'm gonna let's start with you, Richard.
All right, sounds great. So I started at Old Dominion. I ran through a full previous career in my life. I retired from it. Then I had the opportunity to start working at a civil engineering consulting firm. You know, essentially just kind of from contacts that I made or I knew. I had the opportunity. I started as a CAD intern. For me, as soon as I started, which was 6.5 years ago, I started researching immediately, you know, what degree I could pursue to help my career. You know, I knew it needed to be something in the engineering field. So, you know, I was working full time and more. Sometimes I work weeks, sometimes, you know, 50, 60, 70 hours. So I knew there was no way I could do a traditional, you know, school where I go to classes from 10 to 2 in the afternoon. So I knew it needed to be online. So I started looking at online schools. Another big key for me was that I wanted the school to be an actual brick and mortar school. You know, I did not want to have a degree from a school that did not have a campus, you know, where I couldn't go there and watch a sports game or do something if I wanted to. So it kind of came down to only a couple schools. Just seemed to be the best fit for me. So I applied, I enrolled, and I was accepted. I started in the program, which I loved. It's been amazing. The classes are flexible, the classes are amazing. And I'll say one of the first things that became important to me was, can I be an engineer with this degree? Immediately, as soon as I started, and people would ask me about the degree I'm pursuing, and I'd say, well, it's engineering technology. And, I'd kind of explain to them the difference, but immediately became apparent is, can I be an engineer? And I did research, and just like Dr. Flores said, what I found is about 30 states explicitly say within their statutes that engineering technology degrees can be registered engineers. So for me, I went through the program, fee exam. I passed that on the first try, and in all honesty, I loved it. I've spoke with some people with engineering degrees, and they struggled. I just talked with somebody at our company yesterday, and they did not pass it the first time, and I loved it. To me, it was just like a fun question and answer session. So I came out of there feeling great. I did pass it. As soon as I graduated, I was already in contact with about 5 engineering boards. Um, I happen to live in one of the states, one of those 20 that our board, which is in Wyoming, it does not explicitly say it takes engineering technology degrees. It says that the degree has to be in a board approved curriculum. So I have applied to the state of Wyoming to be an engineer, and I'm waiting for a response from them. And whether or not they accept it or not, if they don't, I have about 5 states lined up that I've already been in correspondence with. Their statutes explicitly say they do take engineering technology degrees. They have answered me an email, said absolutely we do. So if Wyoming doesn't, I'll go through there, and I will be an engineer within a short period of time, which was very important to me. And last thing I will say is that the classes were amazing. The applied portion of the classes, our engineers, I work in a company of 500 people. I have people that, have engineering degrees around me, and they're amazed when we talk about my classes. I've done civil engineering design projects where I've taken spreadsheets, nomographs, things that I've developed in those classes, and I've put them directly into a design process. And I've sent them and said, hey, I made this for school. Here it is. I filled it out for this project. Let me know if there's any issues, and never has been. It's been amazing. Well, that's my background for it.
And I am going to add in what you're saying is that we really, in our program, we really get our students ready for the application in the industry. The industry does not have a lot of times. New graduates go to the industry, and the industry have to spend money on training them in specific applications. In our case, our students are ready for them. So with that, I'm going to switch to Eric Beach. What do you have to say, my friend?
So I started ODU back in 2014. It took me about 5.5 years to graduate, but that's only because I worked through it. One thing I will suggest to anybody who chose to do engineering or engineering technology is get an internship. It's a good way to make money, but also it's a good way to kind of take what you're learning in school and figure out how it's going to apply to the field you're going into. I personally have had 2 internships. The first one was a maintenance engineering internship where I worked on preventive maintenance documents for a manufacturing company. And the second one was a design engineering internship at a place called Bauer Compressors. I was there for about 2 years. I was there for about 2 years. And I pretty much did what the rest of the engineers did. They kind of brought me in as a um, new engineer, but they just paid me less really. Actually, right before I left, they brought in a new engineer to replace one of the older engineers who left, and I was the one training him how to do some things, in Inventor and everything. And I got to say, with engineering technology, the reason why I chose to get into it was because I never thought I would ever go into either academia or go into research and development. I never really thought that I'd be the kind of person to go more into the high thinking, the brand new ideas where you had to spend, months doing all the calculations before you can actually start developing a product. I always was the kind of person to just start working on something and make changes later, which is really kind of how I interpret engineering technology. It's really about iteration. It's about how you make the initial the product or whatever you're making, and then you just keep changing over and over again until it meets the standards you need. And that's kind of what it was at my internship, because we designed compressors and we designed enclosures for sheet metal enclosures for compressors and new compressor systems for like nitrogen generation and that sort of thing. And all we ever did was we took pre-existing designs and modified them to the standards we need. So you really didn't have to do the fluid calculations over and over again, because you know the fluid calculations for the one that you're working on the same. So as long as you keep all the pipe runs and the elbows roughly the same, the fluid calculations would be within the margin of error that you need, which is from other mechanical engineering technology students that I've talked to who've gone out into the career field and who've worked at other internships. That's really kind of how it works when you're an technologist. And also, I've worked with a lot of people who had engineering degrees from uh, big name universities like Virginia Tech, and they were doing the same job that I would have been doing if I would continue working in that company. So the idea is that when it comes to engineering technology and engineering, it really, like Professor Flory did said, it really just depends on where you want to go. Because mine was more design. But one thing I also would like to add is that if the way you learn is through hands-on, I would definitely say go to engineering technology, because when it comes to like math and stuff, all that stuff is way too, you know, in your head. And like the first time I took calculus, I actually failed calculus the first time I took it, believe it or not. And I had to ask the professor to give me 1 point to get a D minus so I could take a few engineering classes so I wouldn't be behind. And the engineering classes I took were thermo and dynamics. And I took thermodynamics and calculus again the following semester, and I got an A plus in calculus, and I got a B in thermo and an A in dynamics. And that's because how engineering technology teaches those classes made me understand calculus to the point that I was able to just not even pay attention to my calculus class and ace all the tests, because dynamics went through calculus and so did thermo. Also, I want to point out, I'm also staying as a graduate student. So I'm one of the few people who go from engineering technology into graduate school. I'm staying for a master's of engineering management, which is one of I think it's the only engineering master's that you can go directly into from engineering technology without taking any extra classes. That's more along the lines of project management, how to manage engineering teams and everything. And engineering technology, I was has shaped me into a person that 5 years ago I wouldn't have recognized. So the fact that I'm staying for masters is crazy to me.
But now that you mentioned that, Eric, I'm gonna go back to Richard, because I understand, Richard, you went to grad school. Could you make a comment? And I'm sorry, Alex, I'm gonna go to you, Alex, in a second. But how is the transition into grad school?
It's great. So I am enrolled in graduate school. I begin the first semester I've taken off in 6 years. And similar to Eric, I had always had a plan at ODU to take the engineering management. And then as soon as I graduated and I talked to the people, my own supervisors and the leadership at my company, and we saw Old Dominion has an MBA program that's online, Master's in Business Administration. And for me, this is my second career in life. So, I want to be in leadership roles at our company. And I saw having an engineering technology degree essentially the same, being an engineer though. And then having a business degree, master's degree would really open up great avenues to be in leadership roles at our company. So I am enrolled in the ODU's MBA program, and I start this fall, and I'm really looking forward to it. It's interesting on the the website that we go to view our things, to see my name there listed as a business student now after I've been seeing everything there for 6 years for engineering. But I love the school and I'm excited to start business classes here now.
And just a quick comment based on those two career paths that you guys are choosing into master degree. Those are, I think, first and foremost, those are two master degrees that are very well aligned to the industry expectations into more the leadership roles. That's those two are the best master degree, and our students are very aligned to those master degrees. Anyway, with that, I'm gonna go to Alex. Alex, so what do you have to say? What are your experiences? Alex, could you also talk about your extracurricular activities at ODU?
Yeah, so I'm
engineering
a
technology students. Thanks.
yeah, so I'm a civil engineer. I'm assuming Eric's a mechanical as I know. I don't know what Richard is, but
Civil
I'm
as well.
more yeah. I work at an engineering firm designing subdivisions, which if Richard can take, if you ever take master's classes at Old Dominion, we pretty much learn everything we do at my job in his classes. So it's really, really helpful. And he's a great teacher when it comes to teaching us what the field is like. For my extracurricular activity at Old Dominion, I'm with I'm with a club called Engineers Without Borders. And currently we're finishing up a project where we developed a distribution water system in a community in Guatemala. And we designed it from the ground up. It's a distribution tank that's distributing to roughly 100, 200 homes, if I'm not mistaken. And we're actually finishing the drawings to submit them in over this, I guess in the next 2 weeks, if I'm not mistaken. Orlando?
I was gonna tell you, you better or we better.
Yeah.
So what Alex is talking about is one of the student organization we have on campus, which is Engineers Without Borders. Engineers Without Borders organization, they help communities in need around the world. And in this case, they were assigned a community in Guatemala. They didn't have any direct access to water, clean water, and they had to walk like a mile and a half to a creek to get some water. Now, what they're doing is designing the system
Mm-hmm.
to pump the water to elevated tank, and then from the elevated tank, it gets distributed to all the 201 houses. So we're helping 201 families. And
Mm-hmm.
I believe most of the team are engineering technology. Oh no,
Yeah.
Rita is electrical engineer.
Well,
But
Courtney,
Courtney
Wesley,
civil. Yeah, Wesley as well. So I
Jessica.
would say it's like a half and half. Because at the end, in this type of situation, is the difference is really blurry. You don't even notice the difference between engineering technology and engineering.
Mhm.
Eric, do you want to mention about the makerspace by any chance?
Yeah, I realized I forgot that, which is surprising because it's the only thing I talk about. The Zoom stuff or the online stuff is kind of still hard for me to present on. But part of the reason why I say for a master's is because back in my junior year, I got involved with something called the Engineering Makerspace and Invention Center, which for those of you who don't know what a makerspace is, it's pretty much like a library for engineering students, but instead of having books and stuff, we have metalworking equipment, electronics, 3D printers, everything you need to do practical engineering where you design, build, prototype. Um, so I got involved with that. Actually, Professor Ayala was the reason why I got involved with that. Professor Ayala does undergraduate research, and he asked his class. I think I was taking fluids at the time. Asked his class of some of the students if they wanted to get involved in it. So I went to his office to talk to him about it. And after having a short conversation with him, he pulled me aside. Well, he pulled me towards the makerspace because he said that this would be more in line with me. And I never forgave him because I've been doing the makerspace for 3 years now, and it had made me want to stay for masters in engineering management because I realized that managing is the path I want to go. I realized that I'm a lot better at the engineering aspects when you look at it at a high scale, where, you know, maybe I'm not the one doing all the detailed work, but I can make sure everyone's going the route they need to go and kind of make those big decisions. But for those of you interested, the makerspace is really more aligned to engineering technology, but we have aspects in all engineering fields. Because even if you're a mechanical engineer or an engineering technologist, you're still going to be in the industry dealing with sheet metal equipment, welding. Even if you're not the one actually doing it, you're going to be designing or working on a system that will involve that at some point. So the makerspace is a tool that allows the students to get that hands-on experience. So when you go into the career field, you actually understand how things are made, and if you're designing something to be made by a machinist, you understand the limitations of the equipment and what the machinist can do. um, but also the makerspace is open to all engineering students.
Well, we're almost running out of time. There is one question pending, and I'm gonna send this question to Ike, to Dr. Flory.
Yes.
So the question is from Luis Angel Vergara Ortiz from Hidalgo, Mexico, and his question is: what kind of work or applications could a chemical engineer do if he has an emphasis in engineering technology?
As a chemical engineer,
Mm-hmm.
there are so as a chemical, or if I understand the question, if you already are a chemical engineer and you want to get an engineering technology degree on top of that, or a chemical engineering technology degree, that's kind of what I guess I can explain it both ways. There are chemical engineering technology programs, but they're few and far between. They're very rare because chemical engineering programs in general are not very numerous. And so they really, chemical engineering is not really as popular as mechanical, electrical, and civil, or is in need. So I think in response to that, engineering technology, if you're going to be working in the chemical industry as a chemical engineer, is probably not the best fit. Now, if you're working as an electrical or a mechanical or as a civil in that industry, I think it would be a very good fit, if that makes sense. Yeah. Yeah.
All right, and then with that, I think this has been a great panel. Thank you so much, Dr. Flory, for your insight, for your presentation. Same thing for you, Eric, Alex, and Richard. Thank you so much for giving your vision on how you saw this, how you see your career from your point of view, from the student point of view. I wish you the best. Thank you so much. And with that, we're gonna end the session. Thank you. Thank you, everybody.
Thank you.
Thanks, guys. Thank you.
Thank you.